This question is interesting because they've given us a graph of what appears to be a cubic function. And we can clearly see a single root there because the graph passes through the x-axis at a point. But this is a double root. And the characteristic look of a double root is where the graph touches the x-axis at a particular point, but instead of cutting through like a single root would, it just bounces off. And typically, when you've got a single root, your equation, when factorized, will have a bracket that is raised to the power of 1, whilst your double root will come from a bracket that is raised to the power of 2. So knowing that, we can rule out answer options C and D, which does not have that. Answer options A and B have equations that are exactly the same. And so the only difference between them is that the values of B and C are different. So in order to conclude which one of those is the correct answer, we've got to do a bit of trial and error. I'm going to choose equation A and let B equal to 1 so it satisfies this condition here. And let C equal to -1 to satisfy that condition. And because we're trying to find the x-intercepts, or we're working with the x-intercepts, we also have to let y equals to 0. So let's plug all that into equation A, and let's see what we get. And so we cancel out the minus because dividing both sides by -1 will cancel that out. And so we're left with x equals to 1 and x equals to -1. Specifically that this is the single root and that this is the double root. Clearly, this is not the case. We have a single root on the negative side of the x-axis and a double root on the positive side of the x-axis. So those values are incorrect. That rules out answer option A and reinforces that B is the correct answer.